Greetings and welcome. Today, we'll delve into the latest release of CET.SteelConnDesign, version 1.6, focusing on the beam-to-beam web connection. Let's explore how to seamlessly integrate our software with FreeCAD. Before we begin, we assume that you've successfully downloaded and installed our software. Now, let's get started. To initiate our software, select the CET.SteelConnDesign workbench from FreeCAD. Upon loading, you'll observe some UI enhancements. Notably, a new button, Open Manual, provides a PDF user manual for reference. Within the connection setup options, a fresh addition named Beam to Beam Web awaits exploration. Let's opt for this setup and create two beams. Start by establishing the first beam, Beam 1, and the second beam, Beam 2. Next, select B2 from the beams list and B1 from the other beams list, then create a beam-to-beam web connection named B2_B1. Navigate to the Connection Design tab, where B2_B1 resides in the connection list, accompanied by a visual representation of the beam-to-beam web configuration. This image includes annotations, particularly regarding top and bottom copes. Notably, input for axial force or moment is restricted in this connection setup. Now, click the Design Connection button. Post-design, a single plate connection materializes. Should users wish to refine the system-designed results, adjustments can be made. For instance, modify the top cope length to 5 inches, cope depth to 3 inches, and radius to 0.75 inch. Apply similar changes to the bottom copes. In FreeCAD, users can rotate the model to view connections from different angles. Proceed to the Single Plate Design section and modify the bolt row to 5. You may observe a design failure caused by inadequate edge distance in the beam web. However, you have the option to undo the last changes and restore a successfully passed connection. Now, let's implement other adjustments. Alter the main beam size to W16 by 89. Eliminate the user input for the bottom copes of the beam. Note that in the beam-to-beam web setup, the top elevations of both beams must align. Given the change in beam size, adjustments are required. In the Projects tab, select the B2 member and set the Z-coordinate to 0.7 inch. The depth of W18 by 60 is 18.2 inches, and the depth of W16 by 89 is 16.8 inches. 0.7 equals the difference between 18.2 and 16.8, divided by 2. Afterward, return to the Connection Design tab and proceed to design the connection. This will reveal that only the top beam has been coped. Users can either let our software automatically design the top cope or input their preferred parameters. Additionally, the design summary has been updated to include specific checks for coped beams, such as flexural rupture and flexural local buckling. The design report has been updated to include pictures depicting real member and connection sizes with annotations. Upon opening the report, users will find detailed calculations for coped beam flexural rupture and flexural local buckling. It's important to note that there are differences in the flexural local buckling calculations between the AISC 14th and AISC 15th formulas. Next, inspect the 2D drawings generated by our system. Click Create Drawing and save the files. Utilize a second FreeCAD instance to open the drawings, displaying detailed member and connection illustrations. You'll find that all drawings display the actual member or connection sizes, complete with dimensions and annotations, significantly saving the user's time. Now, select the 3D drawing model and access the TechDraw workbench. From there, you can incorporate an ISO view into your drawing. Additionally, users have the flexibility to customize drawings by adjusting dimensions and then exporting them to PDF for future reference. For the final demonstration, navigate to the Web Connection Design section and switch the connection type to End Plate. Once done, the system will smoothly generate the end plate connection as expected. That concludes our presentation for today. Thank you for watching.